Hi guys, James here. Today I'd like to quickly explain R squared, which is often referred to as the variance accounted for in a statistical model. To begin, I'll take my typical example where we are trying to predict somebody's weight using their age. We will start by examining the univariate distribution of weight, which has a mean near the middle here, and variance, which helps us determine how far a point is away from the mean. So, if I wanted to guess some person's weight, my best guess would be the mean of this distribution, and I would expect that this person's weight will vary from my guess as a function of our variance. Naturally, if I can reduce this variance somehow, then we would expect my guess to be more accurate. So, now I'll plot weight, y, against age, x. It looks like age is a decent predictor of weight. Now, if somebody were to ask me to guess a random person's weight, but they were to first tell me what their age was, I would use this bivariate model to make a more accurate prediction than if I were to only have this univariate distribution. As an example, let's say our age ranges from people 10 to 20 years old. If I wanted to predict the weight of a 10-year-old, this orange line here would be the mean value of weight for people aged 10, and the variance around this mean would be approximately equal to these light blue lines. Again, if I wanted to predict somebody's weight at age 17, the mean value of weight would be this orange line here, with variance equal to the light blue lines. And in this way, age accounts for a degree of the variance that we originally observed in weight. Our guesses become much more accurate when we know a person's age before estimating their weight. Remember that originally, our mean of weight fell right in the middle here, and the variance associated with it was very large. By taking age into account, we've simultaneously been able to account for a large portion of the variance in weight. To understand this fully, let's consider the mean and variance of our 10-year-olds compared to the univariate distribution that does not consider a person's age. By taking age into consideration, we've been able to reduce this much of our variation, and are only left with this amount. In other words, this light blue part represents the variation in weight that we are still uncertain of, and this dark blue part represents the variation in weight that our model explains. If we think of the variation that we explained as a proportion of the total variation in y, then r squared is equal to variance explained over the total variation in y. In this particular case, r squared looks like it is equal to approximately 0.80. So we've accounted for around 80% of the variance in weight, our y variable. Now, let's consider some new models and think about how much variance we've been able to account for in our dependent variable. In this model, every single one of our data points falls right on the fitted line, so there's no more variation left in the model. We've effectively accounted for all variation in y. If someone wanted me to guess the weight of a person aged 10, I would guess this point right here, and our variance would be equal to 0. Therefore, my guess would be perfect, because our model perfectly accounts for all variation in y. So, if I bring this visual back, I can effectively say that all of this is variance accounted for. Therefore, our variance accounted for is equal to the variance of y, and our r squared equals 1. Now, let's consider this model where x doesn't appear to have any relationship with y. If somebody wanted me to guess a 10-year-old's weight, I would guess this value here. If they wanted me to guess a 15-year-old's weight, my guess would be here. And if they wanted a 17-year-old's weight, my guess would be here. What's this? All my guesses would be the same, and it turns out that these guesses are equal to the mean of y with the variation of y. And all our variance goes unexplained by the model, so our r squared is 0. And that, my friends, is how r squared works. Now, in my videos I like to avoid highly technical explanations, but I think it's important that I mention that the precise formula for r squared is often described like this, where r squared is equal to the sum of squares regression over the sum of squares total, where the sum of squares regression is equal to the sum of squares total minus the sum of squares error. These definitions don't deviate from the more casual explanation that I have just given to you, but if you are looking for more information, you're likely to come across these technical terms rather than the semantic ones I have given you here. I hope this video has been useful to you, and thank you for watching.